Okay, to recap and remind you of what we did yesterday, here are our three ways we talked about for triangles to prove them similar. We had side, 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 angle, side, and angle, angle. We talked about how we need to show out all of our information for the sides and angles. We need to show out all of that information. So for the sides, we need to show the proportions. We need to show the fractions and what they simplified to. And hopefully they all simplify the same thing. And then for the angles, we need to show what angles we're saying are congruent and how we know. So that's what we did on this first one. And we ended by saying, here are my two triangles. We have this red triangle here. We have this blue triangle here. And we're going to get started. And this one, these next two actually are going to be examples for side, side, side. And I'm going to show how those work or don't work. So for each of these, I'm going to use the same process that I used earlier on when we first did this, which is that I'm going to match up, start with the shortest side, compare it with the shortest side. And then I'm going to take the middle side, compare it with the middle side. Longest side, compare it with the longest side. Just so that I keep straight which side is going to match up with what. So my three sides in the red triangle, I've got one that's 20, I got one that's 16, and then I got one going this way that's 12. In the blue triangle, from largest to smallest, I got one here that's 15, I got one here that's 12, and I got one here that's 9. So let's start by matching up smallest with the smallest. Thinking about the schedule and all that. 20 divided by 5 is going to be 4. 15 divided by 5 is going to be 3. All right, now we're back in the math business. Now let's take the middle side with the middle side. In the red triangle, my middle side is going to be W to Z, which is going to be 16, over my middle side in the blue triangle. In the blue triangle, my middle side, I have 15, 12, and 9. So 12 is my middle, so that's going to be X to Z. Those are both divisible by 4. 16 divided by 4 is 4. 12 divided by 4 is 3. Remember, the goal here is to have all of these fractions, when I simplify them, they need to simplify to the same thing. They need to all match. And if they all match, then fantastic. They're similar. That's what we're looking for. Smallest side in this one is going to be 12, and that is X to Z. Over smallest side in the blue is this one, Y to Z, and that's going to be 9. So that's going to reduce to, those are both divisible by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. Great news, they all reduce to 4/3. So therefore, these all reduce to the same thing. That means the triangle WXZ, that's my red, is similar, don't forget, use similar, not congruent, similar to my blue triangle. Let's match up all the parts. This triangle is created by a rotation like this. And so that means W rotates up to X. That means that X rotates down to Y. And Z is still Z. By side, side, side. So again, make sure when you're setting up these fractions, you're going to set up shortest side with shortest side, middle side with middle side, longest side with longest side. Let's look at this again in the next one, because this is also going to be trying out side, side, side. I won't show it as in-depth this time. We're going to go quicker. We'll start with the shortest side over the shortest side. Again, I'm going to keep the bigger triangle on top. So my bigger triangle, which one's the shortest side in this triangle? Y to Z, which is 30. Smallest side here. R to S is 24. Those are both divisible by 6. 5 over 4. Middle side with middle side. In my triangle on the right, the middle side is going to be 36. In my triangle on the left, the middle side is going to be 30. So we have 36 and 30. We're going to reduce those. Those are also both divisible by 6. 36 divided by 6 is 6. 30 divided by 6 is 5. Ooh, bad news. 6 over 5 isn't simplifying correctly. Let's triple check and make sure that it's not just that simplified wrong. Let's actually make sure that that's happening over here too. We have longest side with longest side. And when I simplify this, those are both divisible by 3. 33 divided by 3 is 11. 39 divided by 3 is going to be 13. And that can't be simplified anymore. And it's not matching any of these. None of these are matching. Not similar. These are not similar. So, all of them, all the ratios need to match. If there's any of them that don't match, this is why you need to check all 3. If there's any of them that don't match, not similar, even if the other 2 do. So any questions on that? All right. I want you to try these, particularly these next 2. And I want to see how far you get on your own. I'm going to give you about 2 or 3 minutes to look at them and see how far you get. These 2 are a little bit trickier. They are going to be similar, but how we can get the sides and angles that we want are going to be a little bit tougher than the ones that we just did. They're not just all laid out for you. So I'll give you a couple minutes to look at them, see if you can pick out what information we're going to use and what information we can get. So take a couple minutes. Tricky part of these is that at first glance, it's tough to find the information that you need. And so at first glance of looking at these problems, you might have trouble figuring out what pieces that you need. And so you might suggest something like this. Ah, yes, mathematics, one of my favorite subjects. What do we have here? Oh, well, these can't match because quite simply, both of these, this one is 26, you see, and this one is 64. And neither of them are matching. So they can't be similar. Quite silly. And over in these, it says we only have two sides. And one must have either three sides or two sides in the angle that's included in between them. And so I present to you that if there are two sides, that is not three sides. I thank you for your time. All right. Don't know who that know-it-all was, but was wrong on both of them. So, anyone spot what other information on top of what has already been so eloquently presented to you? What other information can we get? Said, well, these angles don't line up, and then these two sides, that's only two sides. So we need something else. So does anyone spot something on either of those two problems that have more information we can get? On which one? So on the first one, you see, yes, we do have a right angle here. So that gives us a pair of angles that are matching up. But how do we resolve this 26 and the 64? If C is not supposed to match up with H, what is it supposed to match up with? It's supposed to match up with K. But we don't know K, so we need to figure out how to get that. And then over here, we either need to somehow know these sides. That doesn't seem very promising because there's no numbers related to it. Or we need to get a pair of angles. It's going to be a pair of angles. So we talked about how to do this one yesterday, and then this one we have gone a little bit over back when we talked about congruent triangles. We haven't actually used this term in a while, but it's one we used a lot last semester, a lot. So we prod you in the direction of one of them. Angles in a triangle. If you don't have this information, then please make sure that you write it down in your notes somewhere. It's going to be important, not just for this chapter, but the next chapter is going to be all about right triangles. And we're going to use this idea a lot. Add to 180 degrees. Doesn't matter what kind of triangle it is, how it's drawn. All the angles in a triangle add to 180 degrees. They have to. And so, for example, in this triangle, we have 90 here. We have 64 here. So 90 and 64, that's a total of 154 degrees so far. And so this last angle, since we have to get to 180, we're already at 154, we need to figure out how much farther we need to go. So let's subtract these, which gives me, let's see, 0 minus 4, 6, 8 minus 5, but this carries out, and so that's a 2. Oh, wow, 26 degrees. Coincidentally matching exactly with this angle over here. So C actually matches up with K. And you can use the same argument over on this triangle. if you want to get used to this idea, try it out yourself, to say that angle E is going to be 64 and match up with angle H. Over here, the pieces that are missing over here are these angles. What are they called? Right across from each other. They're always congruent. They're vertical angles. There you go. So these vertical angles are the included angle between the two sides, and we're going to have side angle side. So these are a bit more complicated ones where you have to piece together some other information that we've talked about throughout the year about triangles. So that's what can make some of these problems trickier. But these two would absolutely be fair game for a test. This one would not. If you had me last semester, then you can watch how we're going to do this one. If you didn't have me last semester, don't worry about it because you might not have talked about it. But I'm going to show you the answers to all of these. I'll let you write in just a moment, but I want to talk about this third one. For those of you that had me last semester, you'll notice these little arrows, you should remember, means parallel, right? That those lines are parallel. And so if we cut this transversal down here, we have that kind of Z shape. Inside the parallel lines, opposite sides of the transversal, alternate interior angles, which means that they're congruent. And then we also, everyone should know that we have vertical angles here. So between those alternate interior angles and vertical angles, angle, angle. We've got them. But for everyone, just worry about these first two primarily, and seeing how we're getting those extra pieces of information that aren't just told to us in the diagram. Hopefully everyone was able to get these simplifying. Smaller side with the smaller side, larger side with the larger side. That's how we want to compare them. And you can put the smaller triangle on top. That's what I did here. Most of the others, I put the larger triangle on top. Doesn't matter. As long as you're matching up, comparing the correct sides, getting them all to reduce to the same thing. So here's your two sides. Here's your included angle. So side angle side. And I got one more homework assignment for you, so I'm going to hand that out while you guys finish writing.